Very good morning to all of you, my dear students. Welcome back to the physics classes. And in this video, this is going to be a really interesting and useful video. We are going to understand the concept of thermometer. What is this device? What are different types of thermometer? What are the different scales or units used in the thermometer? What is exactly thermometer? We are going to explain and understand it all. Okay. So if I will ask you, do you know how many types of thermometers are there out there in the market or in the world? Do you know how many different types of units are used? Do you know how can we convert those units from one to another? These are really interesting and useful things and very simple. Just in this short span of time, we will understand all of these things. Just be with me. So the very first thing here is measurement of temperature. Okay, now what is measurement of temperature? So it says that an instrument used for measuring temperature is called a thermometer. An instrument which is used to measure the temperature is called a thermometer. Okay. Second thing is, most commonly used thermometers are liquid thermometers, my dear students. Whenever you have seen a thermometer, it looks like that thermometer which is shown in the background, and that thin line which goes along, which indicates the temperature. I am very sure you must have seen a thermometer earlier that is filled with some liquid. Most probably in our homes, the thermometers which we were using earlier, nowadays different types of thermometers come. We will also talk about them, but these were liquid thermometer and they were most commonly used thermometers. Thermometers in which liquid, mercury and alcohol are used as thermometric liquids are called liquid thermometer. From liquid of thermometer is termed as thermometric liquid. The word thermometric comes from thermometer and it's called thermometric liquid. Okay, and hence they are also called in turn liquid thermometers. Thermometers are classified on the purpose for which they are used. Whatever we use, for whichever purpose we use a thermometer, we classify it accordingly. All of them have basically same features. Little bit changes are there. What are those changes and how many different types of thermometers are there for us to use, we will see just now. So the first one is laboratory thermometer. Laboratory thermometer, by name it is clear that it is used in laboratories where the temperature can range much more. Okay, from, as you can see in this picture, minus 40 degrees Celsius to 50 degrees Celsius plus 50 degrees Celsius. It is given in this particular thermometer. Okay, this is also a laboratory thermometer, but it has a lesser range. Let's see the postulates. It says it has a very fine glass tube called the capillary tube, having a very thin glass bulb at one end. As you can see in this picture, it has a very thin glass tube. Okay, that whole structure is not the tube. The structure which is in between, the red structure, you can see that has a thick glass coating. Okay, if let me zoom it little bit. Now I am very sure you can see that the red thing is inside that whole glass structure. Okay, and the red liquid which is going, the track in which, as you can see here, the silver track which is present in between, that is called capillary tube. And a very thin glass bulb, thin glass bulb at one end. Okay, and a thin glass bulb is also there at one end, in which the liquid is filled. Okay, now the bulb is filled with a shiny liquid called mercury. Mostly the bulb is filled with mercury, which is shiny liquid, metallic liquid. Okay, then we have the thick glass tube protecting the capillary tube is called the stem. Okay, now the thicker layer which is present on the top of it here, the top layer, the layer which is covering the whole capillary tube and the bulb, is called a what? Stem. Okay, it is a glass layer to protect the capillary tube. Okay, it's called the stem. Then we have the stem of laboratory thermometer has graduations usually marked in degrees from minus 10 Celsius to 110 Celsius. This is the range which is given in the book, but actually laboratory thermometers can be ranged in many different numbers, graduations, okay, depending upon the type of laboratory in which they are used. Okay, okay. So if in examination it comes that what is the range of laboratory thermometer, you will definitely answer from minus 10 degrees Celsius to 110 degrees Celsius, because it is the most commonly used range, and we always write this one only in the examination. But in practicality it could be different. That's why I am showing you this image, that it is not 100% compulsory that to a thermometer to be a laboratory thermometer, it is 100 compulsory that it will be from minus 10 to 110 C, then only it will be a laboratory thermometer. That it's not like that. Why and what makes a laboratory thermometer a laboratory thermometer, we will see right now. For this we need to understand a clinical thermometer. Clinical thermometer is the second type of thermometer which is very commonly used by doctors. The thermometer is used by doctors to measure a person's body temperature. It is known as a doctor's thermometer. It is also known as a doctor's thermometer. The thermometer which you have seen, if ever you have seen a thermometer like this, then this must be a doctor's thermometer, a clinical thermometer. What is special in this? Its speciality, there are two specialities. First one is that it is usually graduated from 35 degrees C to 42 degrees C only, or 94 to 108 degree Fahrenheit only. Okay, only this much it is ranged. Okay, this is because the human body temperature can vary within this range only. Okay, okay, as you can see here, the range is from 110 minus 10 to 100, that means 120 degrees Celsius, okay, more or less. And here the range is only from 35 to 42, that means 7 degrees Celsius. Okay, so it is very small range. Okay, why? Because this much range is enough for measuring the temperature of a body, because it always range between these two temperatures. Okay, okay. The most important feature of this thermometer is the constriction. What is the constriction? The clinical thermometer has a slight bend or kink called a constriction. It's in its capillary tube just above the bulb, okay. This constriction prevents the mercury level in the stem from dropping even after the thermometer is taken out of the patient's mouth. As you can see in this picture, my dear students, here is a little bit of a constriction here, right here. I don't know you can see this or not, but I will try my best to show you this right here. Not right there. Right here. As you can see, there is a small constriction, that means a little bit bend, okay, little bend, a little stoppage in the passage of the mercury, okay. The capillary tube is called a constriction. It is there to constrict the flow of mercury in that capillary tube, so that once the temperature is increasing, the mercury which is present inside that bulb will expand. So it will anyhow push and go into the capillary tube, because it's expanding and it can't expand anywhere else rather than going in that capillary tube. So it expands and passes anyways. But when temperature starts falling, then they have a plenty of room and they are not that much forced to go back, so they stay right where they are. Okay, that's why the main difference between, so why this happens, because we need, after taking it out from our mouth, if it starts dropping immediately, we will most of the time we will take the reading wrong, because it will drop immediately. What happens is, in this thermometer, whatever we need to measure, we keep it there and we put that thermometer into it. Okay, let's say we have a ball here and we will keep the thermometer into it, and we'll keep it looking. Okay, it's 110 degrees Celsius. Oh, it's good. But our body, our mouth doesn't work like that. So if we are keeping something in our mouth and then let's say we are ill already, and even then we are keeping it mouth, we took it out and then we will close our eyes will become little blurry, then we will take it out, then with blurry eyes we will see with the no, no, it's not 94, it's then it will be wrong. No, it's okay, it's 90, I'm fine, I don't need medicine. It will be wrong, terribly wrong. So it have a constriction. This constrictions allows us to what? To measure the temperature accurately even after taking the thermometer out from the mouth or the body. Okay. I hope you understand the basic difference between clinical and laboratory thermometers. Okay. Then my dear students, these two thermometers are also there which are present in the market, but it's not given in the book, so I thought it will be very better if we just talk about it little bit. Okay. So this one is, my dear students, an electrical thermometer. Okay, this one, this blue one, it has a similar type of bulb, but it is not a bulb filled with liquid. It is a reader, what is it called, sensor. Okay, it is a sensor, and this thermometer is battery operated. It senses and it has a motherboard which tells us what the temperature is, and it is an electronic thermometer. It's simple to use. There is a button, and just you have to click on that button and you have to put your thermometer, the bulb, into your armpit or your mouth. Do you know the basic difference between keeping the thermometer in your mouth and your armpit? Always the temperature of mouth is 1 degree more than anywhere of your body. So if you are taking the temperature of your mouth, that means it's 1 degree more, and in your armpit it's always 1 degree less. Okay, and then we have this one, infrared thermometer. Infrared thermometers are very interesting to use. If I had, I don't know where that remote went. I don't have any other remote, or I would have shown to you. You can try it at your home. Okay, infrared light, my dear students, is that light which causes heat. Okay, infrared light is that light which is directly related to heat. Okay, whatever thing is heat, is hot, will definitely emit infrared. Okay, and wherever it is infrared coming, that means that thing is hot. Both are same thing, but I have said it twice in two different ways, because in thermometer we use it like that. Whatever is hot is giving infrared ray, and these thermometers can measure infrared ray to know that this much infrared is coming. That means this temperature, the object from which this infrared is coming, is this much hot. Okay, this is how it works. Infrared light can be seen clearly using a simple machine, using a commonly used machine, which is a remote control. But there is a light, we all know it's infrared, but we can't see infrared. But if you will take your mobile phone and switch on its camera, and then put that remote in front of your camera lens, and then if you will put it on, you can easily see a purple reddish light. That's infrared. I don't know where my remote went. Someday I will show you in my next video. Okay, and then this is infrared. These are used nowadays very commonly to check the body temperature without touching the patient, because there is a spread of coronavirus and we don't want to catch it. So we have invented this one. This was using, we have not invented right now, this was invented I guess 4-5 years ago, 3-4 years ago, but nowadays it is very commonly used because we need it. So these types of thermometers are also there in the market, but mainly in the book we have to study about clinical and laboratory. Okay, in laboratory it is used in labs, it has a very big range. In clinical, it is used by doctors. It has the range of only from 35 to 42 C or 94 to 108 degree F, because our body has only this much range, and it has a constriction which allows us to measure the temperature even after we have taken the thermometer out of our mouth. Okay, then we have these types of thermometers. Now I am very sure you must be very confused about, sir, what is 96.8 Fahrenheit and what is Celsius? Why Fahrenheit? Which to use? What is our body temperature? Fahrenheit, Celsius, and then you told us that SI unit is Kelvin. What is all this? So let me clear this for you. Okay, let's understand. There are three types of units which are generally used in thermometers. Okay, first one is Fahrenheit, second one is Celsius, and then Kelvin. Kelvin is the SI unit. Celsius and Fahrenheit are two different units. As you can see in this picture, excuse me, boiling point of water in Fahrenheit scale is 212 degree F. Celsius scale it's we all know 100 degree C, and in Kelvin it's 373.15 K. Highest temperature ever recorded in US, it's 56.7, and if the Celsius is 56.7, it's 134. We don't have to memorize all these things. This is just to show you that the same temperature, let's say freezing point of water, okay, freezing point of water, if we see here, freezing point of water, so in the middle, in here, freezing point of water, it's 32 degree Fahrenheit, 0 degree C, and 273.15 K. So how different they are. Okay, they are not like this one. If this one is 20, it will be 21 or 25 near it. No, they are very far away from one another and very fundamentally different from one another, these units. Now it's very easy to understand them. Once you know, it's very easy, and if you don't know, it feels very complicated. So let's know it. Okay, what is exactly it? Firstly, let's see what is a Fahrenheit scale. A Fahrenheit scale, my dear students, in this scale was invented by a German physicist, Daniel Gabriel Fahrenheit. So Sir Daniel Gabriel Fahrenheit was a German physicist, and he invented this scale. This much we don't need to understand. This is very easy. Then the thing is that freezing point of water is 32 point F and boiling point of water is 212 Fahrenheit. Okay. Don't need to memorize it right now. Just listen. Okay. Just listen for now. The interval between these 2 points is divided into 180 parts, and each part is called Fahrenheit. Obviously, between 32 to 112, it's 180 units, and all of them are called Fahrenheit, 1 Fahrenheit, and it is denoted by degree F. Okay. Celsius, if we talk about, Celsius was discovered by a Swedish astronomer, Andrew Celsius. Okay, and the freezing point of water in Celsius scale is 0 degree C, and the boiling point of water is 100 degree C. This much we know. And here in Fahrenheit, it is showing that 32 is the freezing point and 212 is degree F is the boiling point. That means 0 degree C is equals to 32 degree Fahrenheit, and somehow 100 degree C is 212 degree Fahrenheit somehow. So how exactly? Let's see. Firstly, that there are 100 different Celsius between 0 to 100, and each one is called a Celsius and written as degree C. Kelvin, also the same cheese. The scale was introduced by British physicist Lord Kelvin. His name was Lord Kelvin itself. That's why he named the scale as Kelvin scale. If I will invent some other scale, I will say it Rishi scale. Why not? Okay, or Raj scale. Why not? I have invented my name, my scale. Okay, so they have also did the same thing, even though they are very great lords and British physicists and everything. Okay, whatever, jokes apart, the scales has no negative temperature, and the lowest possible unit is 0 Kelvin. Okay, they had, what is the main characteristic feature of Kelvin scale? That it has no negative temperature. I think that's why it is given as SI unit, because there will be no confusion. If I say 20, you will know. If I will say 20 Kelvin, you can't ask me, sir, minus 20 Kelvin or plus 20 Kelvin. There are two different types of 20 Kelvin. No, there is only one type of 20 Kelvin, and that's it's plus 20 Kelvin. So there is no negative temperature in Kelvin. Okay, only positive. Okay, and the lowest possible is obviously 0, because 0 is the lowest number, which is no number, and no negative and no positive. Okay, no negative means 0 could be there. Okay, on this scale, the freezing point of water is 273 Kelvin and boiling point is 373 Kelvin. As you can notice that between these two temperatures there are 100 degrees, 100 units. That means it is saying that freezing point of water is 273 Kelvin. That means 0 degree C is equals to 273 and 100 degree is 373. Clear? Why? because this much is in Celsius. So 0 degrees C is equals to 273 K, and 100 degrees C is equal to 373 K. So it's very relative. That means 50 degree will somehow be 50 plus 273. Let's see. The interval between these 2 points is divided into 100 parts. Each part is called a Kelvin and represented by K. Now the most interesting thing, my dear students, relation between the Celsius, Fahrenheit and Kelvin scales. It is very interesting, and if you will learn this, it will help you in your real life many times. Okay, let's say you are traveling in a bus and someone says the temperature, they have a let's say a sophisticated gadget which they are using to flaunt, and they saw something they measured and they are saying, oh, it is showing 100 Fahrenheit. What do you mean by 100 Fahrenheit in Celsius? And if you know the formula, quickly you will tell this much. And you, okay, in which class do you read? In standard 7th. In which school? St. Francis Academy. Okay, that looks as a good school. That feels, because the child is really smart. In real life scenarios, if you use science, na, people get really impressed, my dear students. And that's what I definitely enjoy using science and solving problems in public. I definitely enjoy it. It gives me pleasure. So let's do it and see how we can do this. Celsius and Fahrenheit scales. How we can convert the temperature from Celsius to Fahrenheit and Fahrenheit to Celsius. There is a very simple formula, my dear students. It's called, as in the previous video also we have discussed, but the formula is same, only the formation is different. Here we can also calculate this as, if we put the value of C as C and then divide it by 5, then it will be equals to the value of F minus 32 by 9. And if you will solve this, you can if you have one value, let's say you have C, okay, C as 10, then what is F? So 10 by 5 means 2. 2 is equals to 35 minus F minus 32 by 9. And if you will take 32 by 9 that side, and then the answer will be the temperature of 10 degrees in Fahrenheit. Okay, this is the formula. Whichever you have, you put; whichever you don't have, you calculate. You will get the answer. It is very easy. And then Celsius and Kelvin, if we have to calculate, then it's simply you add 273 in Celsius to get the temperature in Kelvin. 273 it is. Okay. Why only 273? Why not 100? And why even do we need to add? Okay, we need to add because we don't need temperatures in minus. So why 273? Why not 1000? Why not 1000? Why not 500 at least? Because 273 at minus 273 degrees C, something very interesting happens. Exactly at minus 273. As you can see here. Exactly as minus 273, absolute zero. Absolute zero is a very interesting phenomenon. There the if a water molecule gets to the absolute zero, solid, liquid and gas, they are all at the same point together. That is very interesting. I'm telling you just this much, not more than that, because you can get inspired and get interested that, okay, how can a solid and a liquid and a gas be together at one point at the same time when the temperature is at that much in minus? Okay, so it is a very interesting thing, absolute zero. You can explore it, and due to that absolute zero concept, I'm also not 100% remembering, because it's quite a few days I have seen that concept. Few years I guess when I was in school, maybe then only I have heard about absolute zero, and since then I'm seeing it again now only. But it is a really rather interesting thing, and that's why only the temperature of Kelvin is kept like this. Okay, 273 more than Celsius. Okay. So I hope you understand this much, and if you have any questions, please let me know, and if not, then let's go into the Google Classroom, and I have prepared a list of numericals which we will practice right now. Okay, thank you very much. I'm very sure I didn't miss anything and explained everything about this concept. And even if you even now if you have a doubt, please let's talk about it. Thank you very much for watching this video till here.